Hi to all. Today we are going to learn how to design an inverter and how to draw its layout using Cadence tool. So first right click on the desktop, then you will get an open terminal. Click on open terminal, then type Virtuoso ampersand tile VIRTUOSO. Then you will get a window as appeared in video. Then click File, New, Library, and give library name. Here I'm giving library name as test, and then click on attach to an existing technology and press OK. You can select GPDK 45, 90 or 180, depends upon which technology you are using. I'm using here 180 nanometer technology, so I'm using GPDK 180. And then next go to file, new, cell view, and here you need to select the file name which you have given previously. Library, like previously I given a test, I selected the test. Then give a cell. I'm using inverter, so I have given its name as not. Then you can select application, open with schematic Excel or L. I'm selecting Excel as it is advanced version. Yeah. Press I for instance tool. I for instance to drag NMOS and PMOS into your circuit. In library, select GPDK 180. You'll get the NMOS and PMOS and so on. In analog libraries, you can get cell VPulse, VDC, and so on. So here it is NMOS. You can get multiple of NMOS. If to escape from it, type escape, and in cell view type PMOS in place of NMOS and click anywhere on the window. You will get a PMOS. And to move an icon, press M. M is the shortcut to move, and left click on that icon which you want to move, and left click where you want to move. W is the shortcut for wiring. Press T for initializing inputs. Give spacing between the different inputs. It will appear as you give in the order, like first we have given A, so the A has been appeared. Press R to rotate the components, and W is for wiring. Do not drag the icon, just click the icon which you want to move and click where you want to move. Select the direction, whether it is input or output when you are giving input or output. Press P for ports, like I have given in previously, not I for instance only for NMOS and PMOS, and click check and save. Here we got two warnings, that is like always we need to connect the source to body in order to eliminate the body effect. Now it has been shown 0 errors, like schematic has completed with no errors. Now go to create. Now we are going to create a symbol for this inverter. For that, go to create, go to cell view, from cell view. Everything is okay. Click OK and OK. And here you need to design your own shape. Like knot is like we'll get a triangle and a bubble in front of it. So remove the previous thing. You can get a remove from the toolbar. It is in 8th position, and you will get a circle. Select line to draw and oval for circle. Here we get an not gate structure, and press M to move. You can select multiple components once, and you can click it on left and again click. Here we got a not gate symbol. Now click check and save. You can get in Vertiso. You will get in Vertiso that symbol has been created with no errors. Now we are going to check the functionality of the circuit, the schematic which we have given. For that we need to go file, new, and here in the cell we need to give cell name as a new name and select schematic Excel if you are given previously Excel, and you will get a new window. Here go to browse instance, type instance, click on browse and select the library which you have given. Like I have given test, from there not the symbol we have created symbol, right? So select symbol, it will appear as shown in the window. And now we need to give vpulse, vdc and so on. The vpulse and vdc will be appeared in unlocked libraries. Select unlocked libraries, vpulse and symbol to get symbol, and you can edit over there. The DC voltage for V pulse must be 0, and you can change either voltage 1 or voltage 2, it's upon your wish. For CPDK 180, the voltage 1 can be 2 or 1.8, it's not a matter. The delay time you may give as even 0 seconds. The rise time as fall time I am giving as 1 nanosecond. You may give even much smaller. Like in practical we don't get an ideal case like 0 rise time, 0 fall time. And period I have given 20 nanoseconds and pulse width 10 nanoseconds. Pulse width is nothing but how much time it is in on state. And click on OK, hide for that. And press escape for that, and press again I, and now in place of vpulse type vdc. You will directly get a digital signal from that vdc, and you got a 3-volt signal. And now again click I and select the ground for that. Click anywhere in the window, and W for wiring. Now again press P for giving output pin Y. Now give wiring to pin. Now click check and save and check what you saw with no errors. Schematic has been created with no errors. Now it's time to launch ADLE for checking our functionality, and click AC, DC and so on. The trans 100 nanoseconds as it is the stop time. You can select any 3 of the given, conservative, moderate and so on. And now click on the pins. From design we can select the pins and click play button as shown in the toolbar. It is the 4th icon. Differentiate the waveforms as shown in the video. Click on that icon, and here you can see the inverter output. The top one is the output and bottom one is the input. Both are quite opposite to each other. From launch select layout layout GXL, and give the library name as the previous and cell name as the first cell view that we have created schematic, not the test file. And create a generate layout from the left left bottom icon, most left bottom, and press shift F for the this appearing clearly, like you can get a clear view of NMOS and PMOS. And press M to move here also, and remove PR boundaries and select inputs and outputs, and create labels, and move these icons for a better view. Like here the M is the same shortcut to move the components from one place to other. You can select a component as shown in the video. You can press P for extending the polysilicon or the metal, anything. It will simply extend it, and even you can select R for that, and move VDT to the nearest component, like to the PMOS, for our better comfortability. Place exactly on the top of it, not cross or diagonal to it. Like it will be easy for us to draw a layout. See, like we have to clearly attach it as shown in the video. Connect the circuit diagram as per your requirement. And now, after connecting all these, we need to interface the gate and the input also. For that, we need to select an interface of a metal to polysilicon, or you can even call it as via. For that, we need to select O. If we press O, we can get a window for that. And we even need to attach NVEL and P sub. NVEL for PMOS and P sub for NMOS technologies. Like it is nothing but like it is the body, you know, right? Drag all the icons for better diagrams, like better layouts, to its nearest circuit where it has to get connected. P is to extend, shortcut P. And here at the input, press O, select NVEL for the PMOS, and press hide. And you need to closely attach it as shown in the video. There should be no gap or overlaying. It should be exactly on that line. And next, again press O, select P sub for NMOS technology, and click on hide. Don't press up and bottom buttons, up and down buttons. It will be changing, so be careful with that. And it can be placed like the same as we did in the above, and press escape. Now extend the metal of P sub and NVEL and connect it to the source of that respective PMOS and NMOS. To remove body effect, we does so. We connect NVEL and P sub to the sources, and here we want to connect a pin metal to the gate polysilicon. Select M1 poly 1. It is metal 1 to poly 1. And here also we need to attach it very closely, not overlaying it, or we should not leave any gaps between it. Here for undo, you can press directly U. Be careful while these attaching the polysilicons and well piece up and so on. You can select M for moving, P to extend it, the metal. After connecting all the circuits, we need to check any for errors, DRC errors and LVS. It will complete our circuit. After completing our circuit, we need to check DRC if any design errors are there. DRC means design errors. Run DRC. Click on Ashura and run DRC and check technology GPDK 180 and press OK, and we'll get a progress window. Again press OK, and here you can see it has been completed successfully, but the result we have not seen. So here it has been applied. No DRC errors, no design rules check errors. So next, run LVS from same Ashura. We are comparing the schematic versus layout which we have drawn now, and click OK, and same the progress window will appear. Click OK, and there will get if any mismatch between the schematic or schematic and layout. It should come like it has been matched. See, no, there are no mismatches between the schematic and the layout. Press yes, you want to see the result. There we get schematic and layout match. Thank you all. Please do subscribe if you like our video and share, but please do not download it.